Okay, how do I go about starting this question? Josh, what do I do first?
Find the relationship between the two planes.
Okay, what should I do first?
What I did first was I set x and y equals.
No, don't apologize. Find a point where they intersect. Sure. Absolutely. So there is no y here. Doesn't matter what y is in this one. So might as well pick, let's say, y equals 0. So you have 2x plus 5z equals negative 3. And you also have x plus z is equal to?
Negative 2.
So negative 2x minus 2z is equal to 4. Add them together. Not this one right here, but add the top one and that. What do you end up with? Equals what? So z is 1/3. And you know that x plus 1/3 is equal to negative 2. So x is equal to what? Negative what? No. Oh, sorry, negative 7/3. Yes, you're absolutely right. So we have x and z. So we have, here's our intersection point so far. Negative 7/3, comma something, comma 1/3. Oh,
0.
we picked y equals 0. So do we have a point?
Yes.
We have a point. Absolutely. There's one thing about this equation that could be very, very, very different. What? Where they started. Are there lots of other points we could have started at? Yeah, we just happened to pick the same point that they started with as well, which was the easiest one to solve for. Are there lots of other points we could have started with?
Yep.
And would it be the exact same line? Yes, absolutely. So just be careful. We'll do another method in a second. 1, negative 3, and 1. So if we want to find the normal vector, what do we have to find? The cofactors of the cross product. We have to find the cross product. So end up, I always have to write it out. 1, 1, 2, 0, 5, 1, negative 3, 1. So what are we going to have here? 1 times 0 plus 15 I minus negative 1. What is it? It's going to be 2 minus 5 j and negative 6 minus 0. Okay, right? So what do we end up with? 15i, comma what? 3j? Yeah, 3j and what? Negative 6. Okay, so that's the direction vector, right? What do we know about the direction vector? What can we do to the direction vector?
Scalar multiplier.
Scalar, anything we want, right?
In this case, we divide by 3.
So we turned it into 5i. Actually, this is not the best way to write it. Do I write it? I just combined like 3 different ways to write vectors there. It's like this, right? You just, and it's j, not I. Thank you. I just combined it 3 ways and wrote it wrong. Yay, I'm awesome. So we can multiply this by anything we want, because we just care about the overall direction, not the magnitude of the direction. So we end up with 5i plus j minus 2k. So our direction vector, so the vector we're looking for is the direction vector 5, 1, negative 2. So this right here is perpendicular to both. So to both planes.
Where? Normal vector.
Yes, it is normal vector.
Perpendicular to both normal vectors. Thank you. Sorry.
Oh, yes.
Normal vectors of the 2 planes. So it's perpendicular to the line of what? Don't pick a point on the plane you just picked as your plane, right? So what's the easiest way to do this?
Make 2 of them 0.
Yeah, make 2 of them 0. Right, exactly. How about x equals 0, y equals 0, so therefore z has to be?
1.
Yeah, z equals 1. Great. So now we have the point 0, 0, yes, 0, 0, 1. 0, 0, and 1. So we have a plane and a point. Okay, so now is it just plug in stuff? Yeah. So what do we have here? We have distance is going to be, what is it? 3 times 0 plus 6 times
0.
plus 1 times
1.
Negative 3. Yes, minus what?
4.
4. All over the square root of 9 plus 9. So what do I end up with on the top?
7
7 over.
3 root 6. 0 6.
So the square root of what? The square root of 54. So 7 over what? 3 root 6. And if you really want to, you don't have to anymore because we're in AP Calculus and we're above AP Calculus, and even AP Calculus doesn't matter. You don't have to rationalize denominators. What end up with? 7 root 6 over what? 18. Yeah. Done. What's kind of cool, what I find really neat about this is that this will work with any point on that other plane. It'll fix itself, which I find really cool. You might not find it as cool, but I do. So what I end up with, D is equal to, what do we multiply? Well, yeah, 1 times 0 plus 2 times 0 plus negative 1 times what?
Negative 4 thirds.
Negative 4 thirds
Plus 1.
plus 1 all over the square root of 1 plus 4 plus 1.
The root's the same.
That's good. I'm really glad that the root, that's a good sign. If we had something like pi underneath the radical sign, then you know something's really creatively wrong. So what do you end up with up there? You get 0, 0, negative 4 thirds. You get 4 thirds plus 1, so you get 7 thirds over root 6. So you end up with 7 over. Is that the same?
7 root 6 over 18.
I find that really cool. I find that very cool. Again, you might not find it as cool as I do, but I find that very cool.